Okay, I'd like to give a brief introduction to reflection here at the beginning of our light unit. To begin with, imagine a rough surface. This rough surface could be a painted wall or a brick wall or something. And imagine parallel rays of light coming in, striking this surface. Each one of these rays of light might strike some slightly different speck of material. So one of them might reflect off this way, another this way, and so on. And what we would get is an irregular reflection, and as such you would not see an image in a rough surface like that. But imagine we have a very smooth surface. Think of a piece of glass with a layer of silver on the back of it. Now when you have parallel rays of light come in, each one of these reflects, according to the law of reflection, at the same angle, coming out the other side. This would be smooth or coherent reflection, and this is how a mirror works. So let's examine a mirror. Pretend you are looking at a flat mirror, and you have a beam of light coming in. This beam of light is called the incident ray. And as the incident ray comes in, we draw a line perpendicular to the mirror. This line is called the normal. And as that ray comes in, it will bounce, and as you might expect, it will bounce off the mirror, reflecting on the other side, and we have a reflected ray. Let's define a few things here. Our incident ray comes in and makes an angle with the normal. Our measurements of angles always refer to the distance from the normal, and this angle is called the angle of incidence, or theta I. But the reflected ray coming out on the other side makes an angle with the normal that is called theta R, the angle of reflection. And the first law that we can learn here with mirrors is the law of reflection. And this law states that theta I, angle of incidence, equals theta R, angle of reflection. So if the incident ray comes in at 30 degrees, it will reflect out at 30 degrees on the other side. If the angle of incidence is 0, the angle of reflection will be 0, and so on. Okay? Well, if we're looking at a mirror face on, here's a mirror. Here's somebody looking in the mirror. The source of light that strikes the mirror is called the object. And when that light reflects off the mirror, there will be an image formed behind the mirror. And so this is called the image. Now we can define a few things here as well. Just like angles being measured from the normal, the distances here are measured from the mirror. DO refers to the object distance, the distance from the object to the mirror. DI refers to the image distance, the distance from the image to the mirror. And here we get our second principle for flat mirrors, that for any flat mirror, DI equals DO. The image distance equals the object distance.